Okay, folks, so we're going to talk about area of triangles. Now, first thing about triangles is just how to talk about them and how to name them. So we have lots of different types of triangles here, and of course there's way more than just this. This one we're going to go ahead and call an equilateral triangle because it's equal on all sides, 4, 4, 4. We're going to go ahead and call this one an isosceles triangle because there's two equal sides and one that's different. Here, none of the sides are equal, so it is a scalene triangle. It's also a right triangle, so I'm going to call this a right scalene triangle. The only reason I'm calling it a right scalene is because it has a right angle in the corner, but all the sides are different, which makes it a scalene. There's two different measurements. Over here we just have a regular old scalene. There's nothing special about it besides this, the fact that all of its measurements are different. This is, of course, a rectangle. Now, the reason I have a rectangle on here, in order to understand how to find the area of a triangle, you got to understand how to find the area of a rectangle. As we talked about in my last video, area of a rectangle is base times height or length times width, either way, depending on how you want to think about it. Now, the reason I'm addressing that, if I were to take the area of this rectangle, that area would be 8 times 6, which would be 48 square units. Now, why is this related to triangles? Well, it's related to triangles because a rectangle can be thought of as two triangles that are touching at their hypotenuses, meaning their longest sides. So if I wanted to do a light line like that, if you notice, now there's two triangles. I'm going to talk about just this one right here for the sake of right now. If this was 8, that makes this also 8. Now, what did I just do? I just cut a rectangle in half. So if I take this thing, I want to find the area of the triangle, this should be the area of a rectangle divided by 2, or cut in half. Now let's just take that formula and plug it in here. The area of a triangle is therefore base times height divided by 2. I also could think about this as 1/2 the area of a rectangle, so I can also think about this as 1/2 base times height. Either one of these are winning formulas for the area of a triangle. I'm going to go with base times height divided by 2 for the sake of today. So now, how does that work for our triangles? We have lots of numbers on here. Which one do we use? Well, 4 is the base. The height is clearly labeled there. So I'll take that formula, area equals base times height divided by 2. I'll just plug my numbers. Area equals 4 times 3 divided by 2. So area equals 12 divided by 2, which is 6 square units. Notice how I actually didn't use the other two legs. I only needed the base and the height. For the isosceles, I'll do the same exact thing. Area equals base times height divided by 2. Now, what's the base? That is the question. The base is the point from which the height stems. Even if this was turned on its side, like so, it would still be the base right here because that's where the height is coming from. So I'll take that base of 3 times the height of 4, dividing it by 2. So area here equals 12 divided by 2, which is also 6 units squared. What about our right scalene? Where's the base? Where's the height? If I'm looking at it from this point of view, this will be the base, and 8 will be the height. 9 is what's called the hypotenuse. You will not need it for this year. You'll use it in geometry. But for right now, we're going to use the height and the base. That's area equals base times height divided by 2. So area equals 6 times 8 divided by 2, which is 48, divided by 2, which is 24 square units. Our non-right scaling works exactly the same way. 9 is my base. It's the point from which the height comes. My height is 6. Area equals base times height divided by 2. So area equals 9 times 6 divided by 2, which is 54 divided by 2. So area is 27 square units. Ta-da. And showing your work like this is probably pretty smart. You would definitely earn some points from your teachers for showing your work clearly like that. That's pretty much all you need to know for this year. Now, of course, there's ways to work it backwards. Let's say you have a triangle like so, where you know your base is 10. You don't know your height, but you know the area is, I don't know, 20, let's just say. So we can set that up. Area equals, formula we know, base times height over 2. 20 goes on the left side. Base is 10 times something over 2. Now, this is now a two-step equation. I could undo by multiplying by 2. That crossed out becomes 1 times 2. So I have 40 equals 10 times h. I could then divide by 10, divide by 10. I have 4 on this side, which equals the height. If I wanted to plug that in and check my work, which I do, I think it's 4. Let's take our formula. Area equals base times height over 2. So that's 10 times 4 over 2. 40 over 2 does give us 20. So that does work. You could work triangles backwards if you know one of the measurements and you know what is the area. Cool. If you have any questions, please just let me know or just rewatch this video. Thanks. Have a good one.